This separable differential equation example is going to make use of some other laws of logarithms not seen in other examples we have worked. Here we are going to find the general solution to the differential equation 1 plus x squared dy dx minus 2xy equals 0. To begin, we're going to add the 2xy over to the right side of the equation. Remember that we want to separate the x's and y's to opposite sides of the equation. If we now multiply both sides of the equation by dx, you'll notice we have some division to do. We need to divide over the 1 plus x squared so it can be on the right side with the x's, and we also need to divide over the y so it can be on the left side of the equation with the dy. We now take the antiderivative of both sides of the equation. The antiderivative of 1 over y dy simply is natural log absolute value of y. On the right side, though, we need to employ some u substitution. If we allow u to equal 1 plus x squared, notice how du is 2x dx, which is this part right here. So in place of 2x dx, we can substitute du, and we have a u in the denominator in place of 1 plus x squared. If we simply rewrite the antiderivative we are taking on the right side of the equation, then we end up with the antiderivative of 1 over u du. Leaving the left side alone for now. On the right side, we have natural log absolute value, and I'm simply going to put in place of u what we allowed u to equal, the 1 plus x squared, and don't forget your constant of integration. As we've seen in other examples, that's pretty much the end of the calculus, and here on out we're simply employing some algebra and specifically the laws of logarithms. This is another law of logarithms that we haven't seen used yet in earlier examples. Remember that our c is simply a constant, representative, of course, of a number. In order to use one of the laws of logarithms, though, it would be helpful if we had this represented in terms of a natural log instead of that value of c. So I'm going to rewrite c as natural log of some other variable. I'm simply going to call it k. You can choose any variable you wish. Because now the way this is set up, I can easily employ one of the laws of logarithms that says if I have the sum of two natural logs, I can simply multiply the arguments together. I can simply rewrite this as natural log of absolute value of y is equal to natural log of k times this absolute value quantity. Now notice 1 plus x squared is always going to be positive anyway, so I could eliminate those absolute value bars, and I have the natural log of k times the quantity 1 plus x squared. Again, that comes from simply employing one of the laws of logarithms. Now I have the natural log of one quantity equal to the natural log of another. Therefore, those two quantities are equivalent to each other. And I have absolute value of y is equal to k times the quantity 1 plus x squared. Because 1 plus x squared we know is always going to be positive, and this k must have been positive because up here I can only take the natural log of positive values anyway. I can drop the absolute value bars, and we have as our general solution y equals k times the quantity 1 plus x squared.